Okay, so now, basically what happens in this whole chapter 6 is the first part is you start working with the proving part of this, and then the second part of this you are, what is that?
What happened? How did you know that?
Why is that phone on you?
Because it's not trying to put it back there.
Is that your ringtone?
No.
Alright. Now, you go from the proofs to the solving of it. Okay, so now what we've got to do is we're now going to take it to the next level, which is solving using the identities. Okay, so 6.3 was doing a lot of the proof work. 6.4 is actually solving using it to find the actual angles that are satisfy the equation. So I've got the following here. Thunder?
Yeah. Oh, I hope the power goes my phone again.
That's not funny.
It's still going.
Okay, so I start with this right here. Sine 2x plus sine x. Alright? So again, I have to have, my objective here is to have everything so that I can't have a double angle and an angle. I have to have the same angle in order to solve this. So I need to use my identity. So what is the sine 2x identity?
2 sine x cos
2 sine x cos x. That's the one that should be easiest to do. Now, at this point here, I have a binomial term. How do I factor a binomial term? What do I got to do? Yeah, not denominator, but common factor. Yeah. Yeah. So I take a common factor out. What's the common factor here? Sine x. So I take sine x out. What am I left with? 2 cos x add 1 equals 0. So now I need to know where sine x is equal to 0 and where cos x is equal to negative 1/2. Mark, set, go. Where is sine x equal to 0? And what's my domain? Radians or degrees?
Radius.
Radians. So where does sine x equal 0? Where?
2 pi.
2 pi? Okay, just have a look at that domain there. What's the problem with 2 pi?
Where's the domain?
Working example 1.
Oh, it can't be 2 pi. So
Can't be
just
2.
0.
So 0, not just 0.
Or 180.
Radians.
Oh yeah, pi. Yeah, pi. Sorry.
Good. So you were right. 180. Good. Okay, now, where's cos x equal negative 1/2?
2 pi over 3.
2 pi over 3. And?
4 pi over 3.
Yep. And we're done. Okay. Very simple question with a lot of work. But again, if you do not know that unit circle, I am strongly suggesting that you take it home with you and you look at it for 5 or 10 minutes in the evening. Just look at it and try and get it down pat. Because it just makes these questions go a lot faster for you. Alright? This is all new to you. This we need to be able to do without too much trouble or looking. Alright? Second question, 6 sine squared x equals cos x plus 4, correct? Okay, so not only do we not want to work with different angles, a single angle and double angle, we also don't want to work with 2 different trig functions if we can help it. Alright? So what do I have to do here now in order to change it? I don't want a sine and a cos, I want just one or the other. So what can I do?
Bring sine squared back to 1 negative cos squared.
Excellent work. Yes. So I use an identity. In all of these questions we're looking at how do I use an identity to make this question simpler. So now what do I have? 6 minus 6 cos squared x equals cos x add 4. Need to get it all to one side. 0 equals 6 cos squared x plus cos x minus 2. Okay, so I shift the 6 over and a negative 6 cos squared x. I moved it over. Alright. I need to factor it. So I'm going to do this. We'll try this. Okay, actually, yeah, we're going to try and save time. Okay. So this is going to be a bit of work for you. Alright, I need to get a, right now I have like a minus 12. If I take 6 times minus 2, right?
Yeah.
So I need to somehow, what are the factors of minus 12 that I had to give me 1?
4 and negative 3.
4 and negative 3. So I need that. So that means then that I'm going to have 3 cos x here, and it's got to be times by 1. Because I need that. And I know it's got to be a negative, right? So then that means that this has to be plus 2, and this is 2 cos x. So I'm not doing all the factoring for you, like showing you product, sum, factors. You want to try and do this as fast as you can. I have not shown you much of this technique. Alright, there is another way that you can do this, kind of. I can write out my minus 12 here, and I know it's got to be 4 and negative 3, right? So it's got to be that. So now I need to figure out how I get the factors of 6. The factors of 6 are 6 and 1, 2 and 3. And the factors of 2 are 2 and 1. So I need to figure out by one of the, I have to multiply these two numbers by these two numbers such that I get a negative 1 or a plus 1 here. So I go 6 times 12, that's going to be too much, so I can't use that guy. So 2 times 2 gives me 4, 3 times 1 gives me 3. So I make this a 3 times that is a 1, and this 2 times 2. And that's how I end up with it. So I've done it really quickly. If you can't do that in your head, then go back and do the long way. So negative 12, sum has to be plus 1. Factors are 3 and negative 4. Oh, sorry. Negative 3 and 4. So you've got that. And then you plug it in, 6 cos x squared, subtract 3x plus 4x cos x, and go through that. Okay, so the factoring has to be done a little bit quicker, if you can. If you have to do it the long way, do it the long way. Anyways, I'm done. Let's go through this. So I get cos x is equal to negative 2/3, and cos x is equal to 1/2. Alright, so the first thing you do, cos x is equal to 1/2. Where on the unit circle is cos x equal to 1/2? Pi over 3 and there's always 2. Say?
7 pi over?
Oh, 5 pi over 3.
5 pi over.
Yeah, you're close.
That's one over.
Yeah. Okay? That's good. Now I have negative 2/3. This is where, so I'm going to do it like this. Get my reference angle. So get your calculators out. In radian mode, I want the second function cos of 2/3.
Is it going to be a decimal?
Mm-hmm.
Yeah. Of 0.841.
Is that what we get? Okay. What two quadrants is cos negative in? 2 and 3, correct? So I got to find this angle in quadrant 2. So what do you do? In quadrant 2.
Pi subtract.
Pi subtract that number. and then pi plus that number. So what's pi subtract that number?
2.301.
You know what I heard?
Yeah.
Okay, pi plus that number is?
2.983. Or
Alright.
3.9.
Sorry, what is it?
3.983.
Yeah, thanks. There's my solution. Again, these are big time questions in terms of amount of marks needed. It does work with identities. It does work with solving for factoring and solving for your cos values. And then it does work with finding angles. It does work with unit circle angles and non-unit circle angles. These are 4 and 5 mark questions on your exam. There will be one of these questions on the exam. So we need to work through as many as we can. Any questions about this right here? Alright. If you get through this first step, it will always be just factor to here. It won't use anything else. So just know that it'll be a factoring question. Okay? There we go. Alright. Sine squared x equals tan x cos x. So sine squared x equals tan x cos x. Like that. Alright? Okay. Let's change everything to sine and cos. So what is tan? Sine x over cos x, right? Put it in brackets because that's my identity. So what am I left with? Sine squared x minus sine x equals 0. What do I do now? Factor out a sine. Sine x minus 1 equals 0. Sine x equals 0. Sine x equals 1. X is equal to, what's my domain for this question?
360.
360, so where does sine x equal 0?
0.
Pardon me?
180.
Where's sine x equal 1?
90. 270.
90 degrees. But I got an issue here. Okay? When I'm doing these questions, I have restrictions. Because I have fractions, I have to take into account that there's restrictions. So what's my non-permissible?
Oh, 0.
Cos x can't equal 0, right?
Which is
Where does cos x equal 0?
9.
90 and 270. So therefore, that can't be a part of my answer. Okay, so now we're bringing it all together. Now I've got non-permissibles involved. If you can get through this guy, this section, you'll be A-okay, but it's not easy. Okay? Everybody's following so far? One more here? I think one more? No, maybe 2. Alright, cos 2x equals root 3 cos x minus 1. Okay. So which one of the, what do I gotta change? Let me ask you that. What should I change here? Cos 2x, right? So which one should I use to change it?
2 cos square x
Yeah, why did you choose that one?
Because it's the closest to the other side of the,
Yeah. Because this side was already at cos x, right? So that's exactly right. All right? So now I have 2 cos squared x minus root 3 cos x. Add 1 equals nothing, so I got that. So far, so good. So it's not tough so far, is it? Make one identity switch and the question becomes a lot easier, right? What do you want to do now? Same thing I did before, right? Factor. Cos x is equal to 0. Cos x is equal to it says general solution. What does that mean to us?
What's that weird X thing with like the K?
Yeah. It means add 2k pi to your answers. So where does cos x equals 0? Can't use that. You gotta use, because it says in radians.
Pi over 2.
Pi over 2. Yeah. Is that the only place? 3 pi over 2, good. Okay. Add 2k pi, where k is an integer. Add 2k pi, where k is an integer. To me, that's the easiest way to do it. There is another way. What could you have done here? Somebody tell me another way of doing it?
Could you do 2k plus 1 pi over 2?
Every odd value of pi over 2?
Yeah.
Yeah. You could have. I wasn't even thinking that. So yeah, that would work too. The other one would be, I have pi over 2 right here, right? What do I add to get to 3 pi over 2? Pi. So I could have just gone pi over 2 plus k pi. And that would take me back. But by doing it this way, I'm going to use the same method to solve this now. So where in the circle is cos x equal to root 3 over 2?
Pi over 6.
Pi over 6, and where's the other one?
11 pi
11 pi
over 6.
over 6. And then I do the same thing. Plus 2k pi, where k is an integer. Plus 2k pi, where k is an integer. I would do that. I do that all the time. Even though I know the shortcuts, I still go up plus 2k pi each time. Just because it makes it easier to, then you don't have to overthink things. Just go the same all the time and you won't make mistakes.
I don't really get that.
Get what?
Like, for the pi over 2 one and then the 3 pi over 2 one, I know how before you said you could just add pi, but what's the point of doing 2k pi just so you get all the way back to that point? So you could do that, or you can just do k pi. Is that easier?
Just do this. I'm trying to keep it simple for you.
Really?
Put down all of the possibilities between 0 and 2 pi, and then add 2k pi to each one. You can't get it wrong then. Okay? I'm trying to save you work so that you don't have to remember all of this stuff. But yes, I could just add k pi to pi over 2. And that would take me to the next one. And then add another k pi. It would just keep taking you to the following. Every 180 degrees. Okay? The last one is a reciprocal one. So I have 2 cosecant squared theta. X, I guess. Plus cosecant x minus 1 equals 0. Alright, first thing you're going to do is factor. So I need a +1, so that means the 2 has to be the larger and that. So I have that right there. Okay, quick factoring, right? Then that means that cosecant x is equal to 1/2, agreed? And cosecant x is equal to -1. But I don't work with cosecant, I work with what? Sine. So what is sine x equal to here? 2? And sine x equal to? What's sine x equal to here? -1. Where does sine x equal -1? Pi over 2. And what does it ask for? General solution. So every time you go back to it, there you go. There's your answer for that question. Okay? One identity is probably going to be used. This time it was cosecant to sine. You're likely going to have to factor. You're going to have to solve using the unit circle. And you're going to have to solve using your calculator. So the 4 things that you're looking at today. So if you're stuck, look at your identity sheet, bail yourself up. That's kind of what it amounts to. If you're not sure, that's probably on your identity sheet. Alright? Bless you.
Wait, why did we not use 2?
Can't take the second function sine of anything greater than 1 or less than -1.